on prompt caching strategies in AI. So prompt caching is not really about caching. It's about reducing expensive AI calls to AI models, right? So how many of you here know what prompt caching is? Even definition नहीं है तो भी चलेगा. Like roughly, what do you think prompt caching is? Anyone? Prompt caching. Anything? Any more? Anything more? So basically, yeah, I have some pointers. This is my first talk, as we mentioned. So yeah. So it's basically a technique that allows us developers to cache the calls, to cache the context between our API calls and to store and reuse the context between our API calls and the API and the AI model. So every time, yeah. So imagine you are in a coffee shop, right? You are a regular customer in a coffee shop, and I like to have latte with extra foam. So I have a coffee shop in my area. They know my order. So I don't have to go in and tell them every time that I want this. I want this type of coffee, right? They remember and they serve it as soon as I enter. So that's convenient. That saves time, not money in this case, but in AI's case, yes, it saves time. So you don't have to recite. I don't have to recite the recipe every time, and I just say the usual. It's the same with prompt caching. Just a second. Another terminology would be we are serving pizzas, right? Yeah. So for example, if you are a pizza owner, you are working in a pizza shop, and there are 3 different customers who are coming to you and they are saying, I want margarita pizza, okay? And they are asking, how much does it cost? I call my manager, I ask him, like, what's the cost of margarita pizza? But the thing is, for every call, I'll have to spend 10 rupees to the manager. I'll have to give 10 rupees to the manager, right? So for example, there are 3 customers, all of 3 are coming to me and asking me the same question. I'm asking the manager again. So I'm spending what now? Like 30 rupees and plus the time as well, right? Like let's say 5 seconds for every call, so 15 seconds. So that's 30 rupees and 15 seconds extra spend. So instead of that, what I can do is first customer comes to me, he asks me how much is the cost of this pizza. I make a call, I spend 10 rupees, I spend 5 seconds, I write it down. I write down the cost of, yeah, okay, this pizza costs this much. So for every other customers, I don't have to make the call, I don't have to spend money or time. So I save time and money. So that's what prompt caching is. For every API call, your company is spending money, right? Our prompts are not perfect. And yeah, our prompts are not perfect, let's be honest. We can phrase our prompts in such a way that, like for example, if you are, your question is how to center a div. It can be paraphrased in different ways, right? Like it can be, can you please center this div? Or can I align this text horizontally or vertically? But the answer to all of these questions is same, right? So that's where caching comes in place. So there are 3 holy grails of prompt caching. You can see the screen right here. So there is some exact match, normalized and semantic match. Now in exact match, it's basically, it matches everything as it is. For example, if you have asked what is lettuce, okay, and it has a cached value, the stored cache value, okay, and then there is a second call, a third call, and we are asking like what is the meaning of caching. So this won't work when it comes to exact match. It literally compares every word to the cache, to the saved cache, right? So it basically converts, the only thing that it does is it converts it to lowercase, and then it stores and it looks up the exact key. That's it. The pros of this would be it's very fast, as we are only storing and comparing and giving it back. So it's very fast. It's not expensive, obviously. It's just, and we are also not using AI or ML in this. This is the basic level of caching. And the cons would be, it gives about 15 to 20% match. That's it. Because let's be honest, we are not going to repeat our questions exactly as it is, right? Even if you miss a syllable, like what is A Redis or what is Redis, even if A is missing, it won't match. So you are not going to get as many matches as you would want. So that comes, then it is normalized match. Yeah, this is better than exact match, right? For example, again, let's take the div example. Like, if you're saying what is div, how can I center this box? Like, or can you center this box? Yeah, let's take these two examples, right? So what this will do? First, it will strip down all the WH questions: why, what, how. It will strip all of this. So what remains? How do you center a div? So how do is removed? How do is gone? Then it will remove all the like fillers. Basically, we can say filler words like a and the and everything. So what's remaining? Center div. So that's the phrase it will catch on. Okay, and that's the phrase it will look for. In every sentence, even if you paraphrase it, even if you change anything, it will look for center div and it will send you the cache value. So this is still better than the exact match, right? But this also gives like 30-35% of matches, including exact match, right? So it's still not better. So it's faster than it's not. Yeah, it's slower than exact match, but its speed is still okay, and it won't cost you money. It won't cost you money. Then the best caching method would be the semantic match. Okay, this one you can phrase it in any way that you want, right? You can phrase as I'll give you an example. Let's take an example. So if I want to say the first sentence is very basic. How can I center this div? The second I'm asking, I want this div. I want this container to be at the center of the page. This is very different, right? So if you would have used the first two methods, it would not have cached. But if you use semantic match, it will give you the cache value because it understands the meaning of the words and not just, it's not just matching the words. It understands the context behind the words and the prompt that you are sending. So I won't go much deeper in this. This uses something called as embeddings. Okay, so like it gets converted into like a 3D space, like in real embedding, and it then compares with the cosine value. You have to look up to this. If you have to look into this, it's very interesting. So yeah, so for a production level app, you have to use all of these three levels in the lowest and the highest, caching manner, right? So so I would give a real world example of this. Okay, like let's take another example. With no caching, you have like 3 people. As you can see the questions. Like how do I memorize this function? There goes an API call and maybe like 2.5 seconds, it takes 2.5 seconds. And like I said, every API call has a dollar behind it. And we are spending money with every API call. The company is spending money for every API call. So this is costing me like $0.03. And then there is someone else who is saying, how do I use now? These questions are basically same, right? This can be covered as in a single response. So this is also costing you money and time. Again, Rahul is also doing the same thing. Now, with caching, what you're doing is, I have asked one question, how do I memorize this function? I've cached the answer, I've stored it, okay, and I've used all the three prompt caching methods, okay. So now, when Kate comes and she asks, how do I use this use memo? It checks for, it uses all the three methods and it checks, okay, use memo. Use memo, is there a cache for use memo? Yes, there is. So it returns the cache answer. So it doesn't, it will take less time, obviously 0.002 seconds here, and $0. And again for third Rahul, it will cost no money. So if you compare, there are 3 API calls, and with caching, there is 2 API calls. No, there should be 1 API call, and it's comparatively easier, right? Okay, this one is an example of. Okay. So if you see on the right side, right, in a React lifecycle, you have a provider which has to process the entire system, and sometimes it has like you have given tokens for AI models, right? So if you have like 40, 50K, it should, there are like 40 to 50K tokens or more, which can be slow and tedious. So on the first request, the provider can skip like most of the heavy processing, but in the left side, if you see, I'm using Versal AI SDK for streaming. But the key takeaway from here, it would be not the code, it's the architecture. Okay. And so prompt caching is not really a React feature, but I would say it's like we can design smarter apps using prompt caching. That would be the, and I'll end my talk by saying I'll show you the demo of doc generator. So if you see, I am uploading generate readme MD. Okay, it's taking context. You can see context and prompts. So the prompt is using 50 tokens. Step 2, I have it is checking the cache, and you can see cache hit. There is cache hit and there is cache miss. If you miss it, then there will be another API call. If it's a hit, then you can just return the cache. So we have hit the cache, and there is some context, and so we return that. And the same goes with comments and test. So thank you for listening to me. Hopefully you learned something. If you have any questions, you can talk to me with okay. And also, Procedure is hiring. It's remote first company, and we are hiring for full stack engineers, AI engineers, and backend engineers for like 2+ years of experience. And if you want to work on something very interesting, something new, and you want to become a leader and you want to work with AI as well, you can come. You can talk to me after the talk. Okay. Thank you.